minus 0.8 delta naught. There is no pairing energy. Reason? Here also 2 paired, here also 2 paired. Now here minus 1.2 delta naught, minus 0.6 delta naught, 0 delta naught. Next one, sir. Tetrahedral configuration. E first, E1, T2, E2, T2, E3, T2, E4, T2, E4, T21. Correct, sir? E4, T22. Then E4, T23, E4, T24, E4, T25, E4, T26. In this case, same. E1, T2. Yes, sir. E2, T2. Here, E2, T21. Correct, sir? Weak field. E2, T22. E2, T23. Correct? Then E3, T23. E4, T23. E4, T24. E4, T25. E4, T26. Correct, sir? Online. Respond.
Sir.
Then give the value. Minus. I want everything in terms of delta naught. This is minus 0.4. 0.4 or 0.6? Minus 0.6. Delta T can be written as 4/9 times of delta naught. So total value minus 2.4/9 delta naught. So let me write the same. Minus 2.4/9 delta naught. Are you able to understand why I'm writing in this way? Abhinav, Sridarshan. Respond, man. Navanita Krishnan. Sivakumar, Sachin, yes.
Yes, sir.
Is there any cricket matches going on? No, na? Huh? Test series only, na? Test only. For test also, you will join and you will watch movies, watch a cricket match. Huh? Huh? Just a moment, let me open this weekdays target, weekdays material also. Content, JEE chemistry, first step, 2025 batch, quotation marks, right? There I have already calculated this. So here also it will be same or not? Minus 2.4/9 delta naught. Next value, sir? Minus 4.8/9 delta naught. Here also same. Next one. Minus 7 point. E3, man. E3 means 6 3s are 18. 1.8. 1.8 into 9. 1.8 into 9, na? Yeah, into 4. Okay. Minus 7.2/9 delta naught. Here. Okay. One pairing is there. So plus P. Here. It is minus 4.8 by 9 plus 3.6 by 9. Correct? Correct or not? Oh, only one electron, huh? One electron means 0.6 now. 0.6 into 4 by 9. Array, see. This is for E. What we have to write? For E, 0.6 I have to write. For this, 0.4. Correct? 3.6. Then what I have to write? What is net value? This is minus, this is plus. Minus 1.2 plus 0.4 means minus 0.8. Minus 0.8 into 4 by 9. So 3.2. Okay. Minus 3.2 by 9. Next value. Minus 9.6, huh? Plus 2p. Correct? Next, this here. This is 1.2, 0.8, 0.4, 1.6. Correct? Huh? 1.6 by 9 delta naught. Next one. 4 into 2.4. 2.4 and sorry. 2.4 and 0.4 minus 2 into 4 minus 8. So minus 8 by 9 delta naught plus 2p. Next case. Now complete filled. Okay. Half filled. So 0 delta naught. Next. One more electron here. Means another 0.4. Another 0.4 means minus 1.6 into 4. 6.4. Correct? Huh? Response, sir. Is it minus 6.4 or not? No one is calculating. Plus, is there any pairing energy? 1p. Here also 1p. So what about this value? Minus 2.4 by 9 delta naught plus. No need to write pairing energy. Reason? Here one paid, here also one paid. Next one. Minus 4.8. Correct? Here also minus 4.8 by 9 delta naught. Correct or not? Next one. Minus 3.2 by 9 delta naught. Here also same. Next one. 1.6 by 9 delta naught. Here also minus 1.6 by 9 delta naught. Next one. 0. 0. Correct, sir? You need to remember these pairing energies, right? How we got that pairing energies, you need to remember carefully.
Sir, we need to remember pairing energies for all the compounds or how, sir?
No. Based upon configuration, na? How we
Yes,
are
sir.
getting that pairing energy, sir? See. If I take D5, no electron got paired. If it is degenerate, all orbitals have one electron. Now see this configuration. T25 Eg0 means 2 got paired. So the 2 pairing energy I have to write. Clear? Response, sir. Any questions in it?
No, sir.
Now, next point, sir. Actually, this is not in our syllabus, but 2017, maybe 16 or 17, in JEE advanced paper, they framed one question, right? Under the name John Teller effect. John Teller effect. That's why we are discussing this concept. This effect is observable only in case of octahedral complexes. It is observable in case of octahedral complexes. Now, why we are studying this T2G EG? Why we are studying this part EG 2TG or E 2 T2? Why we are studying it? When ligands approach, ligand field will disturb the electrons of central atom. That's why degeneracy of the orbitals are lost, and it will be split into two, T2 EG or T2G EG. Correct? Now, in that also, when I am filling electrons, if electrons are not filled equally, then also they should be not degenerate orbitals. Then also degeneracy should be lost. For example, I am taking D1 configuration. I am taking D1 configuration. T2G EG got separated because of unequal field strengths. And when ligand approaches, that electron field is not symmetrical in all directions. That's why they got separated. When I'm filling electrons, I fill only one electron in 3 T2G orbitals. Correct? If I fill one electron, then remaining 2 T2 orbitals are empty. So they are unequal. Means what happened? Again, there should be some sort of disturbance. That is called Jahn-Teller effect. Is it clear? Due to unequal distribution of electrons among that T2G or EG or T2 or E orbitals, right? Further disturbance is observed. We call that as Jahn-Teller effect. And it is observed only in octahedral complexes, not in tetrahedral complexes. Clear? Now tell me, in octahedral complexes, do D1 shows Jahn-Teller defect or not? Jahn-Teller effect or not? D2, D3, D4, D5, but not here. D5 in strong field shows Jahn-Teller effect, but not in weak field, because here all are equally distributed. Then D6. D6 no here, but weak field it shows. D7. Hey. Here also. D8. D8. No. D9. Yes. D10. No. Right? So, in octahedral complexes, when there is weak field ligand, and in case of strong field ligands. Tell me first, in case of strong field ligand, what about D1? D1, D2, strong field, D4, D5, D7, D9, or D8 means bottom 6, above 2, symmetrical. So D9. Respond. Online, is it clear or not?
Yes,
Online
sir,
response,
clear.
Now, if it is weak field,
Yes.
now tell me in case of weak field. Definitely D1, D2, D3 will not. Reason? T2 is equally filled. D4, weak field, it goes up. D5, no. D6, D7, Are 1, 2, 3, 4, 5, 6, 7. One is empty. Means one is half filled only. So D7, D8, D9, over. Clear? Regarding Jahn-Teller distortion. Because of this unsymmetrical distribution, particularly in case of copper complexes, there will be elongation and compression, right? For example, if I consider na? I wrote spelling wrong, I think. No. See this? Why does it cause a distortion? A molecule with a degenerate orbital is unstable. It will distort to lower its energy and removes its degeneracy, making some orbitals lower in energy than others. Common examples. They have taken D9 configuration because whether it is weak field or strong field, in both cases, D9 configuration shows distortion or not. Right? Leads to uneven filling of EG orbitals, causing complex to distort, usually by elongating or compression along one of the axes. Elongate means maybe axial becomes elongated or equatorials may be compressed. Clear? Better I will take any image of it. I will take this image. I think in weekdays also I have taken this image. Here is we have taken D9 complexes, copper complexes, copper plus 2 complexes, correct? Huh? That too, it is observed in octahedral complexes, correct? Copper plus 2 octahedral complex. Respond. Now, whether EG orbital is unsymmetrically distributed. If it is unsymmetrically distributed, its degeneracy is lost again. If it's a degeneracy is lost, either dx square minus y square may become less or dz square may become less. Right. Both are equally possible, no? If this is lost, now what happened? Dz square orbitals have higher energy, correct? If dz square orbitals are having higher energy and dx square minus y square orbital are having lower energy, means these orbitals are closer to nucleus. So if dx square minus x square minus y square orbitals are closer to nucleus, what happens? It will be compressed. Correct or not? Now here dz square orbitals must be closer to nucleus. If dz square orbitals are closer to nucleus, what happens to repulsions? Increases, and hence they will get elongated, right? So due to unsymmetrical distribution of electrons, these EG orbitals further split to show distortion in octahedral geometry. It will not be regular octahedral geometry. It is a disturbed octahedral geometry. Either it will be compressed along z-axis or elongated along z-axis. Right? Any questions? Online? Is it clear?
Yes, sir, clear.
Now come to limitations of CFT. Open your target booklet. limitations of crystal fit theory. First limitation already we have seen. Are anion, cation, neutral. All are considered as point charges. If all are considered as point charges, which type of point charges will show? Which type of point charges will show more field strength? Which type of point charges should show more field strength? Negative. Correct? But see spectrochemical series, which are strong field ion. Carbon monoxide means neutral. So first limitation. Right? Considering ligands as assumption of ligands as point charges is the first limitation. Second, anions should show greater splitting. But in spectrochemical series, most of the anions are weak field ligands. This is another limitation. Any questions, sir? Respond. Just a moment. Any questions in this? What is the next heading, sir, in your target? What is next heading? Organometallic complexes. First they have to discuss color of complexes, man. Color of coordination complexes. Next heading, color of coordination complexes. We generally know this. Color of complexes is either due to DD transition or maybe FF transition or ligand to metal charge transfer or metal to ligand charge transfer. Correct or not? Right. When ligands approach central atom, what we discussed? P orbitals will be splitted further into T2G, Eg. Now there is energy gap. Now when light visible region, when light falls, electrons from T2G may jump to Eg by absorbing some wavelength. Then the light which is coming out of the complex, having missed that particular wavelength, if that particular color is missing, the color of transmitted light will be different. Or if I pass white light, in that white light, assume yellow color radiation was absorbed for transfer of electron from T2G to Eg. Then the light which is coming out of that complex doesn't have yellow region. Then that light will be having different color or not? What is the complementary color of yellow? Blue. So you will see blue color radiation. So which light is passing to that compound? White light only, but yellow is observed. So you will see blue color. Such complexes will be blue in color. Assume copper complexes are blue in color. Why copper complexes are blue color means they are absorbing yellowish orange radiation. Is it clear? Response, sir. Right? We call this type of color here because of D to D transition. We call it as DD transition. Or if electron jumps from T2G to EG or E to T2, we call it as DD transition. Same way in case of F block elements, FF transition. Right? Any questions? Or if a central atom is having completely empty orbitals, then ligand is transferring its lone pair into central atom. Then it is called ligand to metal charge transfer. If a metal is also having lone pair of electrons and donate electrons back to pi star orbitals, then metal to ligand. So these are the 4 reasons for color of complexes. DD transitions, FF transitions, ligand to metal charge transfer, metal to ligand charge transfer. We call that as synergetic effect. or a metal to ligand charge transfer. It is called. Correct or not? Carbon monoxide. Synergetic bond, right? So here I am writing one statement. Color of complexes is due to color of complexes depend upon wavelength of absorbed radiation. Okay, wa? Correct or not? If it absorb one particular radiation, you will see the color of the complex as complementary color of it. Color of complex compound depend upon wavelength of absorbed radiation. Here the color of complex is there now. Here I am writing complementary color. Any questions? Now observe this one. Observe this, sir. What is the meaning of it? For example, a compound is absorbing radiation between 630 to 590. If this radiation is absorbed, then what is the color of that complex? Blue. If it is absorbing color between 580 to 590, yellow region, then you will see that in purple. If it is absorbing bluish green, red. Clear? All right. Same way in NCERT also they have given one table. This one. Why it is so blurred? Now it is good. Right? Any questions are in this? Observe. COCl NH3 5 times. It is absorbing yellow region, right? Greenish yellow. Then it is absorbed and the color of the complex will be violet, right? So it is absorbing greenish yellow. Then the color of complex will be violet. Are you able to understand? Depends upon what is the wavelength of radiation absorbed. 535 means somewhere here, greenish region, correct? Therefore, it is violet in color. Clear? Say something, man. Right? This is the table what given in NCERT textbook. So we are taking this table as it is. I think we have seen the color of this complex in Werner's theory also. Once go back. See Werner's theory. There CO NH3 5 times Cl. Complex color. There we have taken NH3 or H2O. NH3 only, na? CO NH3 5 times Cl. What is the color? Purple. Here what we have taken? Violet. Huh? Correct? We have taken different. There we wrote purple. Now see, sir, what they gave. So I am not wrong. Right? They only gave it as purple, man. Correct? Say something. NiH3 4 times Cl2 is given as violet. Okay, let it be. Whatever given in NCRT, we'll take that as final. Right? But don't ask me, sir, if they gave this complex, what will write color? Let me check the color. We have to write violet only then, because under specially mentioned under the color of complexes, they give its color, na? What is this color, sir? Violet or purple? Huh? Red. Hey. Is it violet or purple? Hey, not red. You all have color blindness then. Huh? How come it is red? See from there, maroon color. You are wearing that color dress. That's why. Huh? Is it red color? That is problem in projector. Huh? What is this color? Is it violet or purple? Online. Say some color, man. Is it violet or purple?
Sir, purple, sir.
Then we will fix for purple. Right? Next, sir. Don't say anything. Over. Leave it. That is over. Beyond. That is enough. Now note. Shh. Note. If there are no ligands, somehow if I have managed to remove the ligand, then what happens to the color of the complex? So what happens to the split T? Vanishes. Then all orbitals become degenerate. Therefore, color should vanish. Right? Best example. I am taking anhydrous copper sulfate. Observe this. CuH2O 4 times plus 2. Or CuSO4.5H2O. What is the structure? 4 water molecules acts as ligand. 1 water molecule involved in hydrogen bonding formation. Correct or not? Anhydrous means I am removing all these 4 ligands. Then splitting vanished. Then it cannot absorb any color. Then complementary color. If it doesn't absorb any color, means all that light will pass through it. So you will see white. So anhydrous copper sulfate is white. Reason? Degeneracy of d orbitals is not lost. Correct, sir? Then one more thing. I am taking example cobalt complex. I am taking example cobalt complex. Water is the ligand. There is some splitting. Instead of water, if I take ammonia as ligand, instead of that, if I take carbon monoxide as ligand, what happens to the splitting gap? Then what about energy of radiation, wavelength of radiation absorbed? Decreases. Energy gap is more means lower wavelength it will absorb. Then what happens to color of complex? Correct? That's why if ligand changes, color of complexes should change. Means color of the complex depend upon ligand field strength. Correct? So I am writing that point. Color of complex may depend upon color of complex may depend upon that splitting energy, or we will say ligand field strength. Acceptable? I am taking one example. Nickel H2O 6 times plus 2 complex. This complex is green in color. We are adding ethylene diamine bidentate ligand. So this bidentate ligand will remove 2 water molecules. Then it leads to formation of NiH2O 4 times N aqueous. Now its color becomes pale blue. Now again this pale blue complex is allowed to react with another mole of with the second mole of ethylene diamine. Then it forms NiH2O twice En2. Now color may become. Now what happens to splitting gap? 2 ethylene diamines. Splitting gap increases. Correct? Respond. So purple. Now again, when it is allowed to react with third mole of ethylene diamine, violet color. So when strong field ligands approach, what happened? When strong field ligand approach, color of complexes move towards, means absorbed radiation moves towards lesser wavelength. Then complementary color will be corresponding complementary color, maybe moving towards higher wavelengths or moves towards red end, maybe, right? One more data I have to show, sir. Just a moment. One table is there for color of complexes. I'm taking this table, sir. Means if it absorb one particular wavelength, then color of complementary color, what it may be. So that we are going to see, right? Maybe from this table also you can confirm it. So I am writing that part. Under the heading, same color of complexes. In this, absorbed wavelength versus transmitted color. Absorbed wavelength versus a transmitted color. If absorbed wavelength is in between 400 to 450 nanometer, means violet. If it is absorbing violet, then transmitted color will be yellow green. If it is a 450 to 480 nanometer, bluish color. Then complementary color is, what is complementary color of blue? Yellow. 480 to 490 nanometer, greenish blue. Orange. Then 490 to 500 nanometer, blue green. Then it is red. Then 500 to 560 nanometer, green. Complementary color. Violet in brackets, almost purple. Now your problem is solved. Say something, sir. Almost purple. Next, sir. Now, 560 to 575 nanometer, yellow green. Violet. $575 to $590 nanometer. Blue. 590 to 625 nanometer. Orange. Then it is green blue. 625 to 750 nanometer. Red. Then blue green. If energy gap is beyond 400 nanometer. Yes. Okay, ma'am. Hey. Picture. Indigo. First will be violet only, na? Okay, ma'am. Whatever it is. So, no, if that energy gap is more than visible region, then what will be the complementary color? We cannot see. because it is beyond visible region. Na? So if it is absorbing UV rays or X-rays, we cannot see any color. If it is in visible region only, we can identify color of the complex. Clear, sir? Any questions further? Say something. Do you have any questions in this? What is the next heading, sir? What is the next heading, sir? Organometallic complexes. What? The meaning of ultraviolet is almost close to lower ultraviolet region, almost close to bluish violet region. Then its complementary color is yellow. That is the meaning of it. Right? Now coming to this. Organometallic complexes. What do you mean by organometallic compounds? If there is direct bond between carbon and metal, we call them as organometallic compounds. These organometallic compounds may be ionic or covalent. Covalent means maybe sigma bonded or maybe pi bonded. So first one, ionic compounds of electropositive metals. Ionic compounds of electropositive metals. For example, R minus Na plus, sodium methanide, right? Or CH3 minus Na plus. Is it organometallic compound or not? Direct interaction between carbon and metal, right? Grignard reagent, RMgX. PHLi, C6H6 minus Li plus, RC triple bond C minus Na plus, R2Zn. All these are organometallic compounds where metal gets positive charge and carbon gets negative charge, right? So can I say all of them are good sources of R minus? All are good sources of R minus. This R minus can be acting as a good nucleophile, or it may behave as good base also. Response, sir? If there is acidic hydrogen, then it behaves as good base. Correct or not? Okay, for example, same RMgX I have taken, ma'am. And I have taken water. Hydrogen is present on more electronegative atom. Then hydrogen will be acidic. Then R minus will behave as base. So this R minus will take H plus to form RH, and you will get Mg, OH, XOH. Right? Now I am not taking water. Means no acidic hydrogen is present. If it is allowed to react with CH3, CHO, there is no more acidic hydrogen. Then what happens? Now R minus will go and attack here, and this will shift. Correct or not? Now what you will get? CH3, CH. Here you will get R. Here I will get O minus, Mg plus X. Correct, sir? Now R minus is behaving as nucleophile. Respond. So based upon the condition, R minus may behave as nucleophile or may be behaving as good base. Definitely all organometallic compounds are unstable in presence of acidic hydrogen? Yes or no? They are unstable in presence of acidic hydrogen because whenever H plus is there, they will react with that H plus and forms alkanes. Correct or not? Grignard reagent reacts with any acidic hydrogen possessing compound to get alkane as a product. Any questions? Respond online. Do you have any questions in it?
No, sir.
No, sir.
So we are done with ionic compounds of electropositive metals. Now, second, sigma bonded complexes. Sigma bonded complexes. Example, Ziegler-Natta catalyst. What is Ziegler-Natta catalyst? Trialkyl aluminum titanium tetrachloride. Trialkyl aluminum titanium tetrachloride. Ziegler-Natta catalyst. For polymerization of ethene, polyethene, or ethene undergoes polymerization in terms of Ziegler-Natta catalyst to form polyethene, right? Polyethene covers. Tri or tetraalkyl tin, Al2CH3 6 times, etc. All these are examples of sigma bonded complexes. For example, if we take this one, aluminum, methyl, methyl, again methyl, don't write, sir, first listen. Methyl, methyl, and here I am taking again methyl. Do aluminum have empty orbitals or not? Into that empty orbital, these electrons may shift. Then what is this type of bond? Banana bond. 3-centered 2-electron bond. So that's why I'm removing this and I'm writing. Will you understand? Now here between metal and carbon, is it a covalent bond or not? So it is example of sigma bonded complexes. Next side heading, sir. Pi bonded complexes. Already we discussed about pi bonded complexes. G is salt. Hepticity. Respond, correct or not? Hepticity. Example, G is salt. So what is G salt? A platinum, man. Platinum, chlorine, 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 ethene. This is pi electron chloride, right? Same way, metallocenes. Metallocenes. We discussed it already. This is written as eta 2, right? Ferrocene. Example, ferrocene. Eta 5. Iron, eta 5, C6H5 twice. Same way, chromosine. Chromium, eta 6, C6H6 twice. Can I call these are aromatic? Oh. This is about pi bonded complexes. Response, sir. Any questions?
Sir, in chromosine, it will be C6H5 now, sir.
No, C6H6, 2 benzene rings. Here iron oxidation
Okay, sir.
state is +2, Here chromium oxidation number is 0. Okay, wow?
Yes, sir. Yes, sir.
Next, sir. What about this word cisplatin? Discuss this point, sir. Cisplatin. What is this cisplatin? Instead of ethene and chlorine, take 2 ammonias here, right? C5H5 only. Oh, okay. Right. Now cisplatin. I am taking platinum here. Chlorine, ammonia. Right? DsP2 hybridized. Square planar complex. Anti-cancer drug. Correct? And it can have a geometrical isomer also. Correct? Why it behaves as anti-cancer drug? What happened, sir? Feel like something is falling. Not fell down. Why cisplatin acts as anti-cancer drug? This length between 2 chlorines is there now, right? This is perfectly fits with in our DNA strain. When cancer cell is growing, that active sites will be there now. Those will replace this chlorines and they will form permanent bond with platinum. Once it forms that bond, this platinum will not allow this bond length to increase. Then what happens to the growth of cancer cell? Gets arrested. That's how it behaves as anti-cancer drug. So next slide, reading, sir. Bonding in metal carbonides. Bonding in metal carbonides. Yes, sir. Yes, sir. Done. Now see this. I am taking nickel tetracarbonyl as an example. NiCO 4 times as an example. Here nickel oxidation number, sir? 0. Then what is its hybridization? Nickel atomic number 28. Now see here. What is the outermost configuration? 4s2 3d8. What type of ligand carbon monoxide is? Then these two electrons also get paired up. So its configuration becomes 3d10, 4s0, 4p0, and 4d also. It is completely filled. So no d orbitals are free for hybridization, right? All are completely filled, D10 configuration. But how many empty orbitals are required for hybridization? So what should be the hybridization now? So it is sp3 hybridized having tetrahedral geometry. Any questions, sir, in it? Right? Now, if it is tetrahedral, how it will split up? E-T2, or a tetrahedral complex. So now the configuration becomes E4, T2, 6. Correct? Any unpaired electrons? So it is diamagnetic. And mu equal to 0 Bohr magneton. Respond. Any questions? In metal carbonides, which will be donor? Carbon monoxide. Carbon is the donor. Response, sir? Any questions in it? So if you consider CO, molecular orbital electronic configuration of CO is, what is it? Sigma 1s, sigma star 1s, sigma 2s. Go out. So is it 14 or more than 14 electron? 8 plus 6. So pi comes first. So pi to px equal to pi to py, sigma to pz, then sigma star to s, then pi star to px equal to pi star to py, sigma star to pz. Now I need to fill electrons. Totally 14. So 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. Correct? Oh, I wrote star here. Correct only, na? Now can I write this as highly occupied molecular orbital? And what about this? Loom. So if it is donating electrons, it has to donate from sigma star to s. If it is accepting electrons, it has to accept into pi star. That's why it is called sigma donor, pi acceptor ligand. Response, sir. So sigma donor, pi acceptor ligand. Hey, what man? Go, go, go. Can I take this one? Carbon monoxide is donating lone pair of electrons to empty orbital of metal. We call it as sigma. Lone pair of electrons are donated back from metal to pi star orbitals. We call this type of bonding as, what do we call this type of bonding? Synergetic bond. Due to synergetic bond, what happens to CO bond order? And when it is donating electrons back, what happens to this? These electrons go away towards oxygen. So bond order will decrease. CO bond order decreases. Metal carbon bond order increases. Respond. Online. Already we discussed this point. Yes or no? I say something yes or no or something. Huh? Due to synergetic bond, metal carbon bond order increases. Carbon oxygen bond order decreases. Correct? Huh? That nu bars also we have seen one table. Nu bar of CO are energy required to break this bond. Right? Wave number of that bond also we have seen the table. Right. Next one, sir. This metal carbonyl we discussed in case of Mond's process also, if you remember. What is Mond's process? We discussed all these points, man. In order to purify nickel, we'll pass carbon monoxide over the surface of impure nickel. Temperature must be less than 80. Then nickel will combine with carbon monoxide to form complex, which is gas in state. Those gases we will separate, impurities will be left over. Those gases we will collect, and if you heat more than 150, it will decompose, liberating carbon monoxide and pure nickel. Correct? So Mond's process is used for extraction of nickel. Right? We call this process as vapor phase refining process. So what we do? First nickel, which is impure, will pass carbon monoxide. Temperature must be less than 80. Then you will get nickel tetracarbonyl gas. If it is heated above 80, above 150, then it will break back to nickel and carbon monoxide gas. Now you will get pure nickel. We call this process as Mond's process. Right? Next. Another example. FeCO5. FeCO5. Here also iron oxidation number 0. Configuration iron 26 na 4s2 3d6. If these two electrons come back, because carbon monoxide is strong field ligand, so then it becomes 3d8 4s0 4p0 d8. All should pair up. S is empty, P also empty. How many lobes I require now? 5. Done. So hybridization will be DsP3. Then geometry. Hey, DsP3, sp3d, DsP3. Trigonal bipyramidal. Next example. CrCO 6 times complex. Here also chromium is in 0 state. Chromium atomic number 24. Configuration 4s1 3d5. Correct, sir? Now strong field. So 3d6, 4s0, 4p0, 4D 0. 1, 2, 3, 4, 5, 6. S empty, P empty. Then hybridization. P to sp3. Octahedral. Is it inner orbital complex or outer orbital complex? Any questions, sir, in it? Next, another example. Fe2CO9 polynuclear metal carbonides. There are two central iron metal atoms, right? So iron. Between iron and iron, 3 carbon monoxide molecules acts as bridge ligands. Is it clear? Fe2CO9. Another example. CO2 carbon monoxide 8 times. Hydroformylation of olefins. In hydrogens compound chapter, we have seen this. Uses of hydrogen. There are not. Alkenes with carbon monoxide H2. What is this? Water gas or not? Alkenes react with water gas in terms of CO2, CO8. Then what you got? Aldehyde. Correct? Hydroformylation of olefin. This is also called as producer gas because of the same reason. Because it is used in production of different organic compounds. That's why it is also called as producer gas. Right? Syngas. Synthetic gas. Syngas. Right? Used in synthesis of different compounds. Producer gas will have nitrogen also in it. Respond. No. In this case, cobalt. Go. I will give break, man. Once this is over, I will give break. Carbon monoxide. 2 carbon monoxides acts as bridges. 1 carbon bond. Metal interactions are 1 bond between cobalt and cobalt. 1 bond between cobalt and cobalt. CO. How you predicted existence of bond between CO and CO? Here cobalt oxidation number 0. Atomic number. Configuration 4s2, 3d7, 4p0. These 2 electrons also come up. Then what you will get? 3d9, 4s0, 4p0. Now d9. Now how many carbonyls will approach? Totally 8. Totally 8 means minimum 4 for this, 4 for this. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4. Again another carbonyl. Minimum has to be like this. 1, 2, 3, 4. Correct? Now as there is unpaired electron between both cobalt and cobalt, both will attract each other. Then there should be a bond formation. Then what happens to lone pairs of all carbon monoxides will repel? To decrease that repulsions, what they will do? They will form rigid bonds. This bond will now shift here. That bond will now shift here. Right? Both will oscillate simultaneously. So interact repulsive forces decreases. Same way I am taking one more example. Mn2CO10. Manganese, manganese, CO, 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 and one CO here. All forms. What type of geometry it is? Square pyramidal or not? Now there will be one bond between manganese and manganese. And manganese also same man 0, 25. 25 means 4s1, sorry, 4s2, 3d5, correct? If these two electrons comes here, T7, correct? One unpaired electron is there. Then what is the hybridization? 1D, it should be trigonal bipyramidal. When both unpaired electrons approach each other, they will find a bond formation. Then what happens to that? Bottom CO shifts to the plane. Then geometry becomes square pyramidal above, square pyramidal below. Clear? So this is about metal carbonides. Yes, sir. Coordination number. How many ligands are approaching it? Over. Coordination number becomes 5. That one electron is because of that another electron is because of next manganese. When they ask coordination number, there is no problem. Coordination number will be 5 only. 5 ligands are approaching. If you calculate effective atomic number, then there will be a problem. When you calculate effective atomic number, what I have to calculate? Atomic number of manganese 25 minus 0 plus 10. And here also these two electrons are counted along with manganese. Na? Array, this manganese unpaired electron, that manganese unpaired electron. Both are shared by both manganese. Na? Are you able to understand? Now what I have to calculate? Number of lone pair of electrons around manganese becomes 6. And 5 because of carbon monoxides, 1 because of metal-metal bond. Then it becomes 12. Correct or not? So 25 plus 12. Correct or not? 37 it is. Are you able to understand? They might have given 5 2s are 10, 12. They might have given. Means 6 they might have given. Following? Where, man? Question number? Page number? 37, huh? Just a moment. 37. Question number? 47. In which of the following EAN of central atom is different from others? If I take NiCO4, nickel 28, 28 plus 8, 36. Throw it away. Nickel 26 plus 10, 36. Leave it. Iron 26 and plus 3 state. So 23, 23 plus 12, 35. Right? Now manganese 25, 25 plus 1 electron gained from bottom manganese also. That's what I told you. You count this as a pair. Manganese 25 electrons means I have counted it's a one electron or not. Plus one more extra electron I need to count now. Then it becomes 26. 26 plus 10. 36. So which is different? Option 3. Are you able to understand? No questions now? Now same way solve 57 question number. And that is molybdenum belongs to which family? Yttrium, zirconium, molybdenum. Means scandium, titanium, vanadium family. Yttrium, zirconium, niobium, molybdenum. Okay, chromium family. Chromium family means the same as 20 means D5. S1 D5. Correct or not? S1 D5 means strong field ligand means should pair up, so D6. Means it has to be a D2 sp3 hybridization. Means definitely it should be 6 ligands. So it should be CO6. Then it should be 2. Means 8. 8, no, wait. Minus X. Okay. Ru3 CO. It may be 12. 12 plus 2. 14 minus 6. 14 minus 6 means 8. Check the answer whether they have given 8 or not. What they give? 8? How you will know? How you will know? I know the complexes, that's why I gave the answer as Ru3 CO. That's why I am saying I know the ruthenium complex. That's why I am able to. Ruthenium complex will be 3-centered system. Ru3CO9, that is ruthenium complex. This one, it will be like this. Oh, they gave NO also in it. Here, this is Ru3CO9. I know it, that's why I gave that answer as Ru3CO9 directly. Otherwise, how you will? Right? We can take 12. 1, 2, 3, 4. It is 12. 1 minute. Okay. 12 only. Structure is 12 only, man. Okay, 3 centers. 3 centers. Each will have 4 carbonyls. So 12, correct only. Right? Ru3CO12. Right? And H2, what is that? H2 tungsten complex, I think. What is that? Next complex. Tungsten or chromium complex? H2Cr CO6. CO5. This is the complex. Right? Where H2 molecule is coordinated to chromium, where 5 carbon monoxides are present, plus one H2 molecule was bonded to it. H2Cr CO5. One more. What is it? MO. Octahedral complex. Right? So if you know the structures of it, you can solve that answer. Otherwise, it is impossible. Question number 50 or 57. Page number 37. Write down there. Ru3CO12 H2CrCO5 and above one MoCO6. All these are metal carbonides only. Right, sir. Next. What is next idea? Stability of complexes. Go for break and come back by 15. No. I will give break after some time. No, if I give you, you will extend it. What is time now? Actually, your break time is 2:42, 2:50. Yeah. This class is up to 3:30. Yeah. Up to 4 o'clock. Okay. Then after completing this coordination stability of complexes, we will discuss. I will give break. You want break? Now itself. Come back by. You will extend, I know, because it is now 14, na? 3:14. At least come back before 3:30. 15 minutes break, luxurious break. Right? Go, come back quickly. Half of them are sleeping. Online students, you also go for break. Join in the next link, sir.
Sir, it's same or different link?
Different link. Next link is available now. You join in that link.
What time, sir?
Come back within 10 minutes.
Okay, sir.
Right. Size is less means higher the charge, size decreases means charge per unit volume. So charge density is right. So higher the charge density, more stable the complex is. higher the charge density, more stable the complex is. Example, Fe CN6 3 minus. What is charge of central metal? Plus 3 is more stable than Fe CN6 4 minus. Here iron is in plus 2. Same ligands. This is point number 2. 3. Chelation, or we call it as ring formation with ligands, or ring formation with ligands. We also called as macrocyclic effect. Macrocyclic effect. Right? In case of bidentate ligands, for example, ethylene diamine I am considering. What is donor? CH2, CH2, NH2, NH2. Which is donor now? Nitrogen, right? Now if you take Cu plus 2 ammonia molecules, now which is donor? Here also nitrogen only. Right? Here I am taking 4 ammonias, here I am taking 2 moles of it. Total in both cases. How many? What is coordination number? 4. In both cases, all are nitrogens acting as donors. Now among these two, which is more stable means? First complex is more stable because of ring formation. Right? So in case of monodentate ligands, because of their ability to form ring structure, stability of complexes increases. So chelation ligands form more stable complexes than monodentate ligands, correct? So complexes with ring formation, with ligands are more stable. Complexes which form rings with ligands are more stable. And I understood this idea now? No. Generally, which will form ring structures? Monodentate or polydentate ligands? Polydentate ligands can form more number of rings, or EDTA. It can form more number of ring structures, right? So polydentate ligands, if that ligand have double bonds, pi bonds, they form more stable 6-membered rings. If they don't have pi bonds, if there are no double bonds, then they form stable 5-membered rings. Is it clear? Clear, sir, about this point? If they have pi bonds, they prefer to form 6-membered rings. If there are ethylene diamine, do it have double bond in it? So it prefer to form 5-membered ring. Now, if you consider DMG, dimethyl glyoxime. Do it have 5 bonds? Then it will prefer to form 6-member rings. That's all. Right? Next. Crystal field effect. Crystal field effect. As CFSE value increases, as crystal field stabilization energy increases, stability of complexes increases. As CFSE value increases, stability of complexes increases. Down the group means I am moving from 3D series to 4D, 4D series to 5D series, right? As I am moving down the group, every ligand behaves as, in case of 4D and 5D series, every ligand behaves as strong field ligand. Means what happens to that splitting energy gap? Then the complex becomes more stable. Clear? Any questions? No. From 3D to 4D, 4D to 5D, that crystal field stabilization energy or splitting gap delta naught, right? Oh, 1 minute. Will you understand, man? This CFSE, crystal field splitting energy. Will you understand now? Right? Better I will write delta naught if it is octahedral complexes. Right? Increases by 50%. Increases by 50%. Means for a particular ligand, if a 3D, in case of 3D, if the delta naught is approximately equal to 16,500 per centimeter, and we generally measure that energy gap in terms of nu bar. Why? For an electron to jump from here to here, I need to provide some radiation, some energy. Frequency or wave number of the radiation we will measure. If wave number of that radiation is high, means energy gap is high. Right? If it is around 16,500, or assume if it is 10,000, then for 4D, 15,000. For 5D, are you able to understand in that way? Right? It increases by 50%. Now, in case of 5D series, every ligand behaves as almost every ligand behaves as strong field ligand. Next. Additional information, sir. Not necessary, just listen and throw it away. Right? Don't think much. In case of 1A and 2A and early members of D block, means they have larger size. Correct? 1A, 2A and early members of D block. Early members of D block means, can I say 3rd group to 6th group? Correct or not? Or scandium, titanium, vanadium, chromium, maybe up to manganese also, right? Can I say them as more electropositive metals? Can I say them as more electropositive metals? Say something. We generally call them as class A metals. We generally call them as class A metals. They will form stable complexes with smaller or lighter p block elements. What are lighter p block elements? Nitrogen, oxygen, fluorine. Are you able to understand? Right? So they form stable complexes with lighter p block elements as donors. Right? If you take relatively less electropositive metals, relatively less electropositive metals, for example, platinum, palladium, mercury, rhodium, iridium, gold, lead, etc., which are of larger size. Which are of smaller size. We call them as class B. They will form stable complexes with heavier p block elements. Stable complexes with, can I say, higher members of nitrogen, oxygen, fluorine as donors. Okay, will you understand? Right? Next, another note. This point we might have not discussed. 2021 in JEE Advanced, they gave one question. Because of that question, we are going to discuss this. Otherwise, earlier I used not to discuss this point, right? From 2021 only, I started giving this point also. We call it as trans effect, which is perfectly observed in square planar complexes. Because of that question framed in 2021 onwards, we are discussing it. Before that, they have not given. That John Teller distortion also in 2024, they gave the question. That's why we are discussing John Teller effect. Otherwise, no need of it also. So it is observed in square planar complexes. Trans effect. Say what I ate. P block, they are lower members. In that family, higher. Okay. If I drink this coffee today, I have to be in washroom only. Read the trans effect, sir. What it is saying? Trans effect in coordination complexes refers to phenomena where the nature of ligand influences rate of substitution of the ligand trans to it. And if you take square planar complex, right? In square planar complex, if they have 4 different ligands, the ligand, if they are allowed to react with any other ligand, one ligand will make the other ligand which is opposite to it to get replaced by the new incoming ligand. We call that as a trans effect of this ligand. Are you able to understand? Read that. The phenomena where the nature of ligand influences rate of substitution of the ligand trans to it, especially certain ligands weaken the bond trans to them, which are opposite to them. It will weaken that bond, making it easier for the ligand to be replaced. This effect is particularly prominent in square planar complexes, right? And give me 2 minutes time, man. From yesterday, 11:30. Up to 8:30. I have classes continuously. Today morning 8:30 till 5:30. I have class continuously. I took week off. Sorry, one day I have not taken your class now. Oh, on that day also I am not in week. Next Sunday, sir. No chemistry class. Right? This Sunday means today is 3rd or 4th? 3rd. Next Sunday? Saturday 9th. Saturday 9th. Yes. Then next Saturday, Sunday only no chemistry class. Then 16th, 17th, we will have chemistry. I will take 1 week leave. Physics, to what extent it is done? UT, next to UT 3 over. Then okay. Then I will take week off. Already marriage is over. What he will do at home now? Now he will not take any leaves. Whenever there is free time, he will ask, sir, please give classes. Right? Till now he is bachelor now. He will have some time. He wants free time. Now he will not demand for free time. He will say, please occupy me. I am unable to bear this pressure. I thought only that feeling is to me. That feeling is common for everyone. Right? Where is Bitra Nishta? Correct, huh? Nishta? She is not answering. Bitra Nishta, are you there? Hey, she's not there. There. She's there. Right.
Yes, sir.
Correct or not? What I said?
Yes, sir.
Yes, sir. She's answering. Finally. No, proof is recently one more Max sir got married. Till then, every Wednesday, from last 2 years, I am observing. For every Wednesday, he will take, I will apply leave for on Tuesday or on Thursday. Right? I have been observing from 2 years, means 104 times he has taken in that way. 52 weeks. 104 times he has taken. Right? Once he got married, he's coming on Wednesdays also to office. I am coming to that branch. Right? In between he is coming. I'm asking why you are here, sir. Just after lunch for a walk I came, sir. Was walking. Earlier he never came for walking. Now he is coming for walking to office. He is sitting for some time. Then he is going. Sometimes he is leaving every device in class and going out. And after going to some distance, he is coming back. That's right. That is a special gift given to. They know how to. Correct? Huh? Right. Coming to this, sir. Regarding trans effect. Now, what is trans effect, sir? Ligands which are at transposition, to them get substituted. Correct? Huh? Get replaced. Response, sir. Now, in case of sigma donor complexes, for a trans effect in case of sigma donor complexes, will you understand the meaning of it? For a T sigma donor means it is that complex is forming sigma bond and it is showing trans effect, right? Same way for a T pi acceptor. Do you understand? Among pi acceptor ligands, it is showing trans effect, right? Now in this, just a moment. There is one series, nephroxitic series also we need to discuss, I think. See this sigma donor complexes. Now in this case, OH minus less than ammonia less than Cl minus, Br minus, cyanide, methyl, I minus, SCN minus, triphenyl phosphine, trialkyl phosphine hydride. In case of pi acceptor ligands, Br minus, I minus, NCS minus, NO2 minus, Cn minus, CO, C2H4. Example. If you are taking platinum, NH3 4 times plus 2 complex, allowed to react with Cl minus. Now what happens, sir? All 4 are ammonia molecules. Now I am adding Cl minus. Any ammonia I can replace because all 4 are same. Correct? Any ammonia molecule I can replace with Cl minus. So it can form platinum, NH3 thrice Cl minus. Means can I write the complex in this way? Platinum, NH3, 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 Cl. Right? If trans effect shown by chlorine is high, if a trans effect shown by chlorine is high, if I add second mole of chlorine, which will be replaced? Opposite to chlorine, that is ammonia is replaced. Correct? Huh? If a trans effect of ammonia is high, then another ammonia is replaced by Cl minus, because I am bringing Cl minus from outside. If I am bringing Cl minus from outside, if this ammonia is showing trans effect, Cl minus is replaced by Cl minus, no difference. If this ammonia also showing trans effect, another NH3 will be replaced by Cl minus. Clear? Now, it is again allowed to react with Cl minus. Now, observe, among ammonia and Cl minus, which have more trans effect. Among ammonia, Cl minus, which can show trans effect effectively, means which will be replaced. Another ammonia, which is opposite to Cl minus, is replaced. Then what you will get? You will get trans product. You will get trans platinum Cl2 NH3 twice. Acceptable or not? Now, one more example. We are taking platinum Cl4 2 minus complex, allowed to react with ammonia. Now what happens? First step. Among 4 chlorines, any one chlorine will be slowly replaced by ammonia. Any one chlorine. So what you get? N platinum Cl3 NH3. Correct? 1 minus. So platinum 1, 2, 3 NH3. Now, if I want to add one more molecule of ammonia, what happens? Among chlorine, ammonia, which shows trans effect effectively, means this chlorine will replace this ammonia, or this chlorine will replace that chlorine, or that chlorine will allow this chlorine to replace. In any case, both obtained ammonias will be adjacent to each other. Whether this chlorine make this chlorine to get replaced, or this chlorine make this chlorine to get replaced. In any case, ammonia molecules will be. So the product will be cis. Are you able to understand the meaning of trans effect now? Respond. Any questions of it? Respond, sir. Another note. This also '98 or '96. I don't remember exactly. Only once they gave this question. After that, maybe I have misread. Till now, I have not seen any question in JEE Advanced by using this concept called nephloxitic series. 96 or 98, they framed one question. After that, till now, they have not given any question in Advanced, right? So we may skip it, but sometimes bad luck also. Huh? Others' bad lucks may favor us. Or if everyone is bad luck, if we are all having good luck, if they may frame question over this, right? Others' bad luck will favor us. Okay. So that's why next concepts are nephloxitic effect. NaPHE nephloxitic, not came, spelling mistake maybe. Came. Nephloxitic effect, sir. Listen to this. Decrease in Racah parameter. What is Racah parameter means? Inter-electronic repulsions in a complex is called Racah parameter. Right? Decrease in Inter-electronic repulsion when a complex is named.
ITS.
Yes, sir.
So is anyone giving the name for the ITS test series? Anyone going to enroll for it? Online students.
Today Aishwarya is not there, I think, sir.
Available asked for it and Aishwarya asked for it. Two of them apart from
Today Aishwarya there. Aishwarya. She will enroll.
Yes, sir.
You take her name, Aishwarya. Any other? Complete package they are taking. No. Only test series. Okay. You also, huh? There is some amount, I think. What is that amount?
that we don't know, sir. I will just inquire the name.
1 minute.
Actually,
The
doubt
amount
that Ram
also-
Kamal sir is doing, but right now he is not. Only the test series, correct? Adam? Package they were.
Class 11th, 2-3 people are taking. They are taking complete package. Hemant is taking complete package. Hey, I'm saying seriously, man. If you don't, if you are unable to manage time, don't take. If you are confident that, sir, I can manage time, I will attend those tests, right? I will solve those papers, right? Then you are allowed to take it. You are not writing our exams also, regular exams, right? That test series means every 15 days they have exam, I think. 2 to 3 exams, minimum. No, 4 exams, I think. Minimum 4 exams you have to write. Apart from that, our exams also, right? If you are able to, if you feel that I can manage, then take it. That's why I'm discouraging everyone not to take. Directly I'm saying. Because I know you. Okay, wow. What about you? No. 1 minute, sir. 1 minute. Sir. Vitra, Nishita, she can also take. What, Vitra?
Sir,
You will not take, huh? This test series, Invictus. What, madam? What you will do with all money? Spend some money from your father. You know this principle, right? If you don't rotate money, value of money goes down. Already 8 people has enrolled, sir. Pondicherry, he is topper only. Anna Nagar also toppers only. From us, who has taken, sir? Aishwarya is okay. Any other? No, 12th. I am talking about only 12th. Where is Velavan? He okay. Only 2, huh? Then. SW, why? No. You tell Don. No. Tell her not to take. Instead, we will motivate any one of them. Hemarudra, can you manage time? Nishita, Deshna, R Deshna, what's your name? Can you manage? You will see fee structure. Class 12 fees, I think 10,619 rupees.
Only test series.
Only test series. Complete package, no need, sir. For 11th, okay, they will have some time. 12th, they will not have time. They can't even open the books. What? Any other? Your name Sweta? Sweta. You are from Karaikudi. Can you manage? Then okay, leave it. Tarun Krish. Any other? In our class, we are not able to find good people. Hmm? Sir, that Abhinav,
Oh, sorry, Abhi.
PSV Abhinav,
Yes, sir.
you can enroll, right?
Sir, for test alone, I am thinking.
For test alone, man. Not for complete package. We can ask Abhinav, sir. Abhinav, is there any other? Sridarshan Jay Kumara? No. Jay Kumara, Ellen Kumara. Who is the topper from Velamma?
Maybe is there any Sridarshan Jay Kumar only?
Jay Kumar only, na?
Yes, sir.
Okay.
For those who have been elected for that, Jay Kumar only, sir.
Spotlight, huh? Then we can ask that Jay Kumar, na? Yes, PSV Abhinav. Will you enroll?
Sir, for test alone, how we can do, sir?
How can we do means?
Sir, test alone means how much it will be, sir?
Test alone is, that's what I'm saying. Test alone is 10,619, I think. This one, test series
Okay, sir.
only. Right? Any other? We can ask the Sridarshan also, sir. He's also managing good averages only. Any other? Okay, we will not demotivate. We'll encourage everyone. But this is the condition. If you know that, okay, sir, I can manage time. I can take that pressure. I can attend all the exams. Then it is useful. If you are not attending the exam, what is the use of taking it? Test series becomes waste. Okay? That's why please take, if you are interested, you can take. Right? That's enough, sir. Okay, fees is this much, sir, 10,619 rupees. And our test series, this also, syllabus have you seen? First target. Based upon that, you have mains exam followed by advanced exam. Again, second target, one mains, one advanced. In that way, we have 6 targets. On every target, you will find one mains, one advanced, followed by full. No. Weekends, it is 24 hours slot. Anyhow, you can give in missed test also, no issue, right? But those questions will be really tough questions. If any one of you enroll, na, then I can see the papers also. So that if you bring that papers, we will solve, right?
Sir,
Why? What difference they have given?
excuse me, sir.
Is it? Yes, sir.
Sir, in this test, if we miss one test means, can we write it again after some time or how, sir?
One test means?
Sir, if we by chance miss one test without writing it in the allotted time,
Then that test will be available
we
in
write it
missed
again?
test. You can write at any time.
Okay, sir.
Right. Then I don't know about fee structure. This is the only data I have. Right? Definitely not more than this. That I can assure. If they have revised, I don't know much. Okay, leave it. Now, nephloxidic series, sir. So what it says? When ligand approaches towards a complex, if ligands form a stable complex, then repulsive interactions between them decreases. We call it as nephloxidic effect. Nephloxidic series of ligand. The list is shown below. Common ligands with increasing nephloxidic effect. So what happens? When iodine is approaching, what it will do? When it forms complex, repulsive forces between iodine molecule, iodine ions decreases. If it is not able to form stable complex, repulsive forces will be high. Now, in case of metal ions, does not only depend upon ligand type, but also depend upon central metal ion. These two can be arranged in the order of increasing nephloxidic effect as follows. Manganese, nickel, molybdenum, rhenium, iron, iridium, cobalt, manganese. Manganese plus 4. This is manganese plus 2, I think. Plus 2. Right? Any questions, sir? find any better image available if. Once read this statement, derived means from Greek meaning cloud expanding, describes the phenomena where d orbitals of a metal ion expand upon complex formation with ligands, resulting in a reduction of interelectronic repulsions. Means if central atom is there, when ligand is approached to form a bond, the d orbital electron cloud move away. If the d electrons move away, what about distance between lone pair of electrons? Therefore, repulsions, we call that as nephloxidic effect. Is it clear? Thus, this effect observed in transition metal complexes indicates a covalent character in metal ligand bond, challenging the purely electrostatic model of, according to crystal field theory, what it says, between metal and ligand interactions or ionic interactions, but nephloxidic effect says covalent bond. Is it clear? Interelectronic repulsions. In free metal ions, electrons repel each other, leading to certain level of interelectronic repulsions. This repulsion is measured by using beta Rocha parameter, right? When ligand approaches, what happens to that interelectronic repulsions? Decreases. Means Rocha parameter beta value decreases. Okay, B value decreases because we are using beta as stability constant. Complex formation. When a metal ion forms a complex with ligand, the d orbitals of metal ion can expand due to overlapping with ligand orbitals, leading a greater spatial extent among d orbital electrons. This expansion of d orbitals reduces interelectronic repulsions between d orbitals, causes a decrease in Rocha parameter. The decrease in Rocha parameter upon complex formation is a strong indication of covalent character between metal ligand bond, as the electrons are shared between metal ion and ligand. Nephloxidic series. Ligands can be arranged in a nephloxidic series based upon their ability to cause this effect, with more covalently bonding ligands, leading to a larger decrease in beta. For example, ligands like I- causes larger reduction in B. That's why you see this. I- will have more nephloxidic effect, right? Want to take better image now? This is nephloxidic series of ligands, okay? Nephloxidic effect of metal ions. Oh, relatively, this is the only image better than that. Okay. We will not bother much. Let it be as it is. Any questions about this, sir? Okay, ma? Next one, sir. That's enough. What is the next slide heading? Applications of complex compounds. This theory, can I directly show? Only applications means quantitative, qualitative analysis, those things, right? Applications of complex compounds. Yes, sir. Yes, sir. Yes, sir. So I'm closing this. Direct, I will show that from our completed notes. See, sir. First one, detection and estimation of metal ions. How to detect nickel and percentage of nickel present in aqueous solution by adding dimethyl On adding dimethyl nickel form red color precipitate confirms presence of nickel. Now we will filter the precipitate. We will take the weight of it. By measuring the weight of that precipitate, we can compare what is the weight of nickel present in that given solution. Are you able to understand? So for detecting and estimation of nickel ions, forming DMG complex, it forms hydrogen bonds also. Any questions in it? Same way copper. Copper is estimated by using cupron, which is benzoin oxide. This is benzoin oxide. Copper is forming simple. Instead of CH3, take benzene ring. And this is dimethyl na? In that, remove the CH3 group, place phenyl group. Then it is called benzoin oxide. Right? Now, same way cobalt can be estimated by using alpha nitroso beta naphthol. Alpha nitroso beta naphthol. It forms red color precipitate. Here also red precipitate. Here also cherry red precipitate. Now iron with 110 phenolphthalein, 1,10 phenolphthalein, it forms brown precipitate. So by using these type of ligands, we can estimate nickel, copper, cobalt, iron, etc. Right? For identifying and estimating metal ions, we can use formation of complexes. Now, calcium, magnesium, lead, they can be estimated by adding EDTA. Next, extraction of metals. Already you know this Mons process for extraction of metals. Another one, MacArthur Forrest cyanide process. Gold or silver metal. If it is present, generally gold and silver are obtained as nuggets, having some impurities in it. So we will break it, make it as a powder. Then we will add potassium cyanide, KCN. We call this as a leaching process. Gold or silver dissolve by forming a complex with cyanide in presence of oxygen. On adding zinc, zinc will replace them, making them to get precipitated. So this is how we will get pure silver and gold. We call this process as MacArthur Forrest cyanide process. Any questions in it? Next, vapor phase refining. Zirconium, when heated with iodine, it forms ZrI4 when it heated up to 870. If it is heated up to 1800, it will break down to produce pure zirconium. Same way titanium also. Impure titanium with iodine forms TiI4. When temperature is above 1700 Kelvin, you will get pure titanium. Same way nickel also. On passing carbon monoxide up to 80, it forms nickel tetracarbonate. If temperature is greater than 180, it will decompose to get pure nickel. Any questions? Next, biological systems. Photosynthesis are green pigments of leaves, right? Chlorophyll form complexes with magnesium. Red blood pigments. Iron form complexes with, right? Globin, protein, na? Globin is protein, porphyrin nucleus, right? Now, vitamin B12, cobalt form complexes, right? Because that's why it is called cyanocobalamin, right? Cobalt complex, which is in case of deficiency of B12 leads to pernicious anemia or blood loss or something, it says. Correct or not? Now, as catalyst also we can use complexes. Wilkinson's catalyst, Ziegler-Natta catalyst, right? This is applications of complex compounds. That ends this chapter, right? Do you have any questions in this? Done? Right. Shall we go to next chapter or don't ask for break? Except that you can ask anything. Can we go for alkyl and aryl halides? Next chapter, sir. Shall I complete? If it is Amines chapter, I can complete this chapter in this 1 hour. Amines, small chapter. No, polymers. Polymers also small chapter. Within 1 hour, I will close it. Polymers. Oh, what, madam? You are fighting with her? Huh? Will you solve numericals of coordination compounds or shall I start any chapter? Your choice. Chapter? Which chapter? Hey, already I decided. You said chapter, I decided for chapter. Which chapter you want? That's all. Halo alkenes only, yeah? Okay then. Halo alkenes and haloarenes. Right, sir. Open your target booklet. Haloalkenes, haloarenes, sir. In introduction, first there is a classification of alkyl and aryl halide, correct? Classification based upon number of halogen atoms. So first we will start from there. First one, sir. Classification based upon, yes, sir. Hey. Go. Classification based upon number of halogens. First one, monohalogen derivatives. Or at least from here, listen carefully, man. Coordination compounds, very, very important chapter. Minimum 2 questions you will get. Alkyl and aryl halides, minimum 2 questions. Alcohols, phenols, ethers, 2 questions. Aldehydes, ketones, carboxylic acids, 2 questions. Amines, biomolecules, polymers, chemistry in everyday life. These 4 are very, very small chapters. Amines, hardly 1 lecture it will take. Amines, biomolecules, polymers, chemistry in everyday life. Right? These 4 minimum you will get 2 questions. Understood? So listen to them very carefully. First one, monohalo derivatives. Monohalo derivatives means organic compounds having only one halogen. CH3X, is it monohalo derivative? CH2 double bond CHX, is it monohalo derivative? Correct or not? CH2 double bond CH single bond CH2X, is it monohalo derivative? CH3 CH X CH3, is it monohalo? CH3 CX CH3 CH3, is it monohalo? But this is present on tertiary carbon. That's why. Is it tertiary halide? This one. Secondary halide. This one. We call this carbon as allylic carbon. So it is example of allyl halide. This is vinyl halide. This one, methyl halide. Hybridization of this carbon, sp3, sp2, sp3, sp3, sp3. Response, sir? We will take one more example also. What about this one? Is it monohalo derivative or not? And we call that carbon as benzyl. Response, sir. This is benzylic carbon, right? So what do we call it as? Benzyl halide. No. If I have taken on benzene ring halogen directly, now halobenzene. Observe the difference, sir. This is benzyl halide. This is halobenzene, or we call it as aryl halide, right? This is sp3. This is sp2 carbon. Now what about this one? CH3, C triple bond, CX. Alkynyl halide, correct? Huh? Say something, sir. Okay, don't get confused. Okay, now is it alkynyl halide or not? This is alkynyl. This is alkynyl. Anyl, enyl, inyl. Done? Any other examples they have given? Let me open. Me also, I will also open it. I think it is in power step. I think so. That also. Okay, I will complete that. From last carbon, if a second carbon have a methyl group, from last carbon, second carbon, if it have a methyl group, then we call this group as iso. Right? Now, if you have a halogen here, so I call it as isopropyl halide. Right? If from last carbon, or I will take example also. An example of this is isopropyl chloride, correct? Huh? What about this one? Now, sir, can I call it as iso? If I have this, then I call it as iso. Now, can I call it as iso? Now, I am changing that in another way. Now, can I call it as iso? Now I call it as isobutyl chloride. Right? Now observe the same. I am writing that in this way. Instead of writing chlorine here, oh, chlorine, huh? Instead of writing chlorine here, I am changing the position of chlorine to this place. Observe the difference. CH3, again CH3. Observe the position of chlorine. I am changing from here to here. Don't call it as iso now. Reason. From last second carbon is not having only CH3. It is having another CH3 also. Right? Then it is tertiary. Carbon connected to 3 carbons. So this is tertiary butyl chloride. Understood? Now if I take anything like this, CH3, C, Cl, CH3, CH2, CH3. Now, sir, tertiary 1, 2, 3, 4, 5. Tertiary pentyl chloride. Now I am changing the position of chlorine and methyl again. CH3, C. I brought this CH3 here and chlorine here. Now it is called neopentyl. From last carbon, second carbon, if it have 2 CH3 groups, then neo. That means that carbon must be quaternary carbon. Now it is neopentyl chloride. Any questions? Do you have any questions in it? Any other? Do they give any other example? That's all? No need to discuss about IUPAC names now. You already know, right? Now, second, dihalo derivatives. Dihalo derivatives. I am taking one example. CH2Cl2, sir. CH2Cl. Just a moment. right? Dihalo derivative, CH2Cl2. Now what we call it as? Methylidina. And if two chlorines, two halogens on same carbon, we can use the word idine. Response, sir. Idine or not? What is the name of this one? Okay, don't say IUPAC name. Dichloromethane. Common name. Methylidine dichloride. Right? If you take something like this, CH3, CH, chlorine, chlorine. Now, what is the common name of it? Ethylidine, ethylidine dichloride. Not MW. SW0. Right? Ethylidine dichloride. Right? If two halogens are on same carbon, we call them as geminal dihalides. Now, what about this one? CH2, Cl, CH2, Cl. Here also two chlorines are there on adjacent carbon. So what we got as ethylene dichloride. Observe the difference. This is ethylidine dichloride. This is called ethylene dichloride. We call them as vicinal. Geminal, vicinal. IUPAC name, sir? 1,2 dichloroethane. This one 1,1 dichloroethane. Is it clear why it is called idine? Right? Ethylidine. Now what about this one? Methylidine dichloride. Or I can call it as 1,1 dichloromethane. Any question, sir? No. If this is allowed to react with alcoholic KOH, what happens, sir? Very, very famous reaction. If this is allowed to react with alcoholic KOH, aqueous KOH shows substitution. Alcoholic KOH shows elimination. So OH minus act as base. What base will do? Pull acidic hydrogen. Correct? Huh? Respond. Right? Okay, first I will write aqueous KOH. If I write aqueous KOH, what happens? OH minus will go on. Replace chlorine. Substitution reaction. Reaction proceed via SN2 mechanism. Right? SN2. Now, what is the product? CH2, OH, OH. If same carbon have two OH groups, H2O is eliminated. So what you got? Formaldehyde. Response, sir. You will get formaldehyde or not? Or it is also called as formalin. Or IUPAC name is methanol, NaL. Respond. Any questions in it? Oxygen, oxygens, lone pairs will repel, na? That's why on same carbon atom, if you have two OH groups, I have to eliminate H2O. If you have three OH groups, eliminate only one H2O. Right? If you have four OH groups, eliminate 2 times. If the size of atom increases from carbon to silicon, it can bear 2 OH groups. From silicon to germanium, you can bear 3. Right? Same if you take phosphorus, it can bear up to 3 OH groups on it. If you place 4 and 5th OH group, then H2O is eliminated. H3PO4. If size of central atom increases, what happens? Distance between OH and OH group increases, no? Then repulsive forces decreases, so they can exist. If the size of central atom decreases, both OH groups come closer, then repulsive forces exist, then H2O gets eliminated. Clear? Any questions in it? Online? Anyone alive?
Alive,
Yes, sir.
Yes, sir. Then
Yes, sir.
good. Now see this. For example, I am taking dichloroethane. If this is allowed to react with aqueous KOH, what happens, sir? So product will be CH2OH, CH2OH. What do we call it as? Ethylene glycol. We call this as ethylene glycol. Indirectly, I am revising reagents. What happens in case of KOH aqueous? What happens in case of alcoholic KOH? In case of alcoholic KOH, what happens? Elimination. Here, substitution. Here also more stable carbocation is not possible. That's why here also I will say SN2. And here, ethena, vinyl chloride. The elimination of HCl, na? Alcoholic KOH is good base. First good base, what it will do? It will go and pull H plus out. If it pulls H plus, you will get anion. Then that bond shift here, Cl minus goes out. Right? So reaction will proceed via E2 mechanism. Again, I am writing CHHCl bond CHHCl. Now what happened? OH minus will go and pull this H plus out. Correct or not? E2 mechanism. Correct or not? So product will be CH2 double bond CHCl. Right? 1-chloro ethene. Alcoholic KOH cannot remove second HCl. Correct or not? If I want to remove again HCl, what I have to do? Sodium amide, NaNH2 in presence of ammonia. Now again HCl will be lost. Again elimination reaction. Now the product will be HC triple bond CH. Correct? Terminal alkynes. If I don't use ammonia, then what you will get? C minus Na plus, C minus Na plus. Reason, acidic hydrogens are replaced by, it means NaNH2, na? It forms Na plus, NH2 minus. NH2 minus will take H plus. Again, NH2 minus will take H plus. So what you get? C minus, triple bond, C minus, Na plus, Na plus. Due to presence of ammonia, that ammonia provide H plus ions. Right? Clear? Or better, I will write one thing. Terminal alkynes have acidic hydrogens, correct? Any questions? No. KOH can remove only HCl once. It cannot remove HCl from more electronegative carbon. Percentage character enhanced. As percentage character enhanced, breaking that bond becomes tough. Therefore, I have to use even stronger base. So NaNH2 is stronger base. Instead of KOH, alcoholic KOH, in beginning itself, if I use NaNH2, then directly you will get alkyne. Understood? Online? Understood or not?
Yes, sir.
Yes, sir, understood.
No. We cannot differentiate geminal and vicinal dihalides by using NaNH2 in presence of ammonia. Yes or no? We cannot differentiate between vicinal and geminal dihalides by using NaNH2 in presence of liquid ammonia. Yes or no?
Yes, sir.
Why? Both will give same product. There also what happens? First HCl is lost to form vinyl chloride. Again HCl is lost to form alkyne. So we cannot differentiate vicinal and geminal. So if I use alcoholic KOH, what happens? Then also we cannot differentiate. Correct or not? But if I use aqueous KOH, we can differentiate. On adding aqueous KOH, vicinal gives ethylene glycol, but geminal gives acetaldehyde. What, sir? Two H groups are same carbons. So to differentiate geminal and vicinal, the alcoholic KOH is preferable or aqueous KOH? Understood? Right? I am showing that again. If I use aqueous KOH here, what I will get? OH. If you have same two OH groups on same carbon, H2O is eliminated. If H2O is eliminated, CH3, CHO. Right? What we got? Ethanol, NaL. If I use alcoholic KOH, what happened? You will get again CH2, CHCl, correct? If I use NaNH2, again same. Respond. So that's why to identify vicinal and geminal, which is preferable, aqueous KOH is preferable because you will got different products. Right, sir? Any other examples do they give under dihalo derivatives? Under dihalo derivatives, do they give anything else? Dichlorobenzene, okay. I am taking one more example then. Now see this. This is also. What is this? If I use KOH aqueous, what you will get? Can we get benzaldehyde? Response, sir. Is it dihalo derivative or not? Ardho, meta, para. Right? Now, which have zero dipole moment. Now, in case of dipole moment, which will have high dipole moment? Ardho greater than, meta greater than, para. Now, if you want to check boiling point, which is having higher boiling point. In case of ardho, net dipole moment is there, right? Means molecule becomes polar. Next molecule also polar, means they will attract. Are net dipole moment is there, no? Correct or not? In this direction. Correct? If I keep another molecule, then also net dipole moment is there. Between both attractions will be there. Then in order to separate them, I need to spend energy. So boiling point will be high. Understood? So boiling point of ardho is greater than. Once there is, check the table, sir. Page number 71. They gave one table. No. One minute. Page number 79. They gave one table. Check. Yes or no? What they give? Boiling point, which is having higher value. Reason. Ardho dipole moment is there. Therefore, attractive interactions are high. Therefore, boiling point is high, no doubt. Then what about meta and para? Dipole moment is less, very less, negligible. Here it is 0, but it is symmetrical. Then packing occurs more readily. Then boiling point enhances. Now observe melting point value. Hey, check. Melting point, hyper. Para, ardho, meta. Very, very important bit, sir. Right? Of course, previous JEE mains question as well as NEET question. Advanced related question. Right. Any other example they gave for dihalo derivatives? Any example? Melting point depends upon molecular interactions and also packing. Right? Now, if you have groups closer to each other, only in one direction, what happens to lone pair repulsions? Increases. When lone pair increases, repulsions increases. If I take one benzene ring, second benzene ring, is it possible to bring closer? Then what happens to density? They occupy more space when density decreases. Then less energy is sufficient to separate them. Therefore, melting point will be hyper, para, because I cannot bring that chlorine either in this direction or in this direction. Are you able to understand? That's why para value will be high. Effective packing. Respond. Say something, sir. What something, sir? You are accepting anything. Listen again. In case of para, molecule is symmetrical. Symmetrical molecules can be arranged more effectively. Then what happens to volume? Density? Then packing. So I have to spend more energy per unit area. Correct or not? Then melting point will be. So in case of melting point, effective packing enhances melting point value. Point 1. Effective packing, symmetrical. If molecules are symmetrical, melting point will be high. Correct? In case of boiling points, check for molecular interactions. If two molecules are attracting, then boiling point will be high. Over. In case of melting points, we need to check for packing. In case of boiling points, we need to check for molecular interactions. Enough. Clear? Next, sir. Now, trihalo derivatives. Check. In trihalo derivatives, any other examples they gave? Now, third point then. Trihalo derivatives. Trihalo derivatives. Are online? Anyone there or everyone left?
Sir, 19 people are there, sir.
Sir, we are here, sir.
Right, sir. People joining in the meeting is different, but listening to class is different, na? Huh? Correct. 1 minute. Ardho will have more repulsions only in this direction, na? What about this side? Correct. Then packing will be possible. Oh. Now coming to trihalo derivatives. Can I take chloroform? CHCl3. We call it as chloroform. Trichloromethane. Used as anesthetic. Correct? In olden days, which is used as anesthetic before invention of chloroform? Nitrous oxide, N2O. Laughing gas. Right? L2O is used as anesthetic. I think during the time of Elizabeth, I think so. It has one history. 1 minute. Queen Elizabeth, she doesn't want to give birth to baby because she felt like, why I have to bear the pain? I am queen of so many countries. Her at that time, England, Queen of England. No? So that's why for her, they found this compound in order to make her to sleep. You know this history or not? Chloroform was first used on. I think they will say name of that scientist. Definitely he might have slept first. Huh? Was used as an anesthetic by Sir James Young Simpson, a Scottish obstetrician. In 1947, he introduced it to practice after discovering its anesthetic properties. While it was initially met with enthusiasm, its use declined due to safety concerns and the rise of either as a safer alternative. This one. He first used it on November 12, 1847 during a delivery, making the first documented instance of chloroform being used as an anesthetic. To whom no one is saying. Where? By Queen Victoria during the birth of Prince Leopold in 1853, further boosted in public profile and so on. Who is this Queen Victoria? There is that bloodline changed. You know this, no? Elizabeths are not actual bloodline of original England founders, correct? Scottish. Elizabeth belongs to Scottish. You know this or not? The Braveheart movie, have you seen? If possible, watch that movie. You will understand. Okay, leave it. It becomes history class. It was first used by Queen Victoria. Queen, that's why they found it. Same way, one more medicine, sir. Syphilis disease. You know this history of this, no? What, man? Yes or no? All these are fun facts. Quiz of chemistry, man. In quiz of chemistry, you never participated in any quizzes. Neither you watch movies, nor you study well, nor you come to classes regularly. You will not write exams properly. You will not even participate in any other activities. Then what you are doing? Do you know what people will be called in that way? Parasites. Literally, they will call such people as parasites only. Are you parasites or you will participate in such activities actively? You will live as parasites only. Like, don't be that. Participate in some activities. At least learn the facts. Whenever you are free at home, if you feel bored, remember any topic, search, learn for it. Improve your knowledge based upon that. Instead of wasting time. Don't only play games, video games. Or not, don't spend time in Insta, making reels, nonsense stuff. What's Sweta? Right. So used as anesthetic. If this is allowed to react with alcoholic KOH, now tell sir what will be the product. If it is allowed to react with alcoholic KOH, what alcoholic KOH do? First, it will go and pull acidic hydrogen. Yes or no? So if acidic hydrogen is pulled out, can I write CH3C minus is obtained? Correct or not? OH minus. This is CH, Cl, Cl, Cl. This OH minus will pull H plus, right? Then what it will form? C minus, chlorine, chlorine, chlorine. All chlorine are more electronegative atoms. What electronegative atoms try to do? Now they can go out. So Cl minus is lost. Then what you will get? This orbital becomes empty. Chlorine, chlorine. Now I will not write negative charge. I will write this as lone pair. Because Cl minus is gone means I have to write one more plus. Empty orbital means plus and minus becomes neutral. So that's why this negative charge I will write as lone pair. What you got? Carbene. Respond. So what you got finally? CCl2 empty orbital. Carbene. What type of elimination it is called as? Can I call this as alpha elimination? Because both hydrogen and halogen both are lost from same carbon. Or we can call it as 1,1 elimination. Alpha elimination, or can I call 1,1 elimination? H is gone from first carbon, chlorine also gone from first carbon. What about this one? This elimination is called 1,2 elimination, beta elimination, right? So this is example of beta elimination or 1,2 elimination. Clear? Among carbons, singlet and triplet, which is more stable? Triplet carbons are more stable than singlet. Why? Why, sir? Why? Hund's rule of maximum multiplicity. How many times we discuss? Spin multiplicity will be maximum. And what is spin multiplicity value? Formula for spin multiplicity. 2 into summation of S plus 1. Correct? What is spin value? Half, half. 1. 2 into 1 plus 1. That's why it is called triplet. Here spin value 0. 2 into 0 plus 1. That's why it is called. So where spin multiplicity is maximum? That's why we call it as Hund's rule of maximum multiplicity. Where spin multiplicity value is maximum, that becomes stable. So triplet is more stable than singlet. Respond. Similarly, if I write CHBr3, what we call it as? Bromoform. CHI3, iodoform. Iodoform color, yellow. Right? Any other they give? Try halo derivation. Oh, on benzene ring, huh? Okay. 1, 2, 3, trichloro. Trichlorobenzene. No. How many isomers possible for trichlorobenzene? Number of isomers possible. And all will be positional isomers only, man. So change the position of only one carbon. How many isomers possible?
3. The fourth.
4.
Setting the chlorine first carbon, we can get third carbon.
Correct. Hey, that bottom and keeping this one carbon chlorine here, both are same. I understood your thought. Both will be same only, na? What he is saying is chlorine, chlorine, chlorine. Possible? Is it isomer or not? Now, another possibility. Chlorine, chlorine. Whether I place this chlorine here, both are same. Now, placing that chlorine here, same as first. So moving the third carbon, chlorine. I am not moving the third chlorine. I am moving the second chlorine. If I bring the second chlorine here, same only both. Now I am bringing that chlorine here. Is it same or different? Over. Is there any other possibility? That's all, right? So 3 isomers possible. Correct? That's all. Whatever you do, you'll get 3 isomers only. Now, any other example? Oh, then tetrachloro-derivative. Huh? Next one, sir. Fourth one. Tetrachloro-derivative. CCl4. Now see here. CF4 existence is difficult. CBr4 also difficult. CI4 doesn't exist. Only CCl4 exists. Why CF4 doesn't exist? Or why it is difficult to make CF4? Carbon fluorine bond is smaller and fluorine is small in size. Then what happens to distance between carbon and fluorine? Then what about remaining all 4 fluorines? Becomes close to each other. Every fluorine have 3 lone pairs. So all will repel each other. Then what happens? They try to move away. If they try to move away, what happens to carbon fluorine bond? Breaks. So leave. Now carbon fluorine. Fluorine is relatively larger size, it moves away. So CCl4 we have taken. What about CBr4? Bromine size. Then 4 bromines will repel each other. Then CBr4 also difficult, relatively less stable. CI4 impossible. 2 iodines. On same carbon, 2 iodines itself is not possible. On adjacent carbons also 2 iodines not possible. If you have 2 iodines on adjacent carbons, I2 will eliminate forming alkene. Are you able to understand? On 2 adjacent carbons also, if you have 2 iodines, I2 will eliminate forming a double bond. On same carbon, possibility to form 4 iodines is not even imaginable. Is it clear? So CCl4. Very good solvent. Right? Carbon tetrachloride. Or can I call it as a tetrachloromethane? IUPAC name. Right? Very good organic solvent. Commercial name is Pyrene. Is the name of the company which used to prepare CCl4. Name of the company which prepared CCl4 is Pyrene. That's why CCl4 is also called as Pyrene, but it is commercial name, company name, not compound name. Right? Compound name Pyrene is also there. This compound is called one minute, sir. Small mistake I have done. Right? Whether you have pi bond here or not, I don't care. Right? If I have a pi bond here, then it is called Pyrene. This is the name of the compound. This is the name of company. Right? Old JE mains question, sir. Which among the following is also called as pyrene? They have not given this. Answer is CCl4. Nowadays, it is not pyrene. In earlier, they used to call it as pyrene, commercial name. This is the compound name. It is aromatic compound. Pyrene compound. Aromatic. Whether it is aromatic or not, check once. Do it obeys Huckel's 4n plus 2 pi electron rule? Yes? This central pi bond not involved in conjugation. So whether that pi bond exists or not, even if that pi bond is not there, then also it is aromatic compound. Obeys Huckel's pi electron rule. Clear? Any other they have given? CCl4, good solvent, carbon tetrachloride. Any other? Do they mention anything about CCl4? That's all. Next one. Hybridization already over. Array. Next classification based upon hybridization already we have done. Next one. Classification based upon sp2 hybridized carbon over. Next one. IUPAC nomenclature over. Next one. Nature of CX bond. So next side heading, sir. Nature of CX bond, which we will discuss in next class. Right. Online 16 people, 3 people already left.
Yes, sir.
Morning 27 people, afternoon 27 people joined. Slowly it became 19, now it became 16. Right, sir? Nandri, Vanakkam. Bye, sir. Good night.
So this
Thank you, sir.
class,
Array, Wednesday, we will have class. Surface chemistry. Yeah. Yes. You are saying something, madam.
yes, sir, that only I asked. Wednesday class is there only.
Yes, sir. Wednesday class is there. Surface chemistry. Bye, sir. I will end the session.
Thank you, sir.
Bye, sir.